Hey, it Tens, how's it going? You guys make me laugh every time. The chat is hilarious. Ashley, I'm so glad that you are so excited over being first in the lesson. Well done. It's amazing. Okay, just checking that the sound's okay. So we've got Ashley, Moses, Rue. I'm just going to do the register. Got Harris, got Rue. Has no one seen Nick yet? I haven't seen Nick yet. Ashley, of course, first in the room. Seen Ashley, seen Shan, seen Anna. Haven't seen. I know that Kira's. Sorry, you haven't seen Kieran yet. Yours here. Nick's here. Amazing. I haven't seen Kieran. I haven't seen Kieran yet. Or Toby. Is Tong in the room? Yeah, there's Tong. Ben. Andy. I've got Vic. Got Isabel. Got Ruby. Got Moses. Haven't seen Con yet. Hi, Ben. Good to see you, dude. Got Wen. Got Tong. Got Ben. Got Ruby. Has anyone seen Toby? Toby, Kieran, Andy, and Con. And I know that Nick's here now. There's Con and Kieran. Amazing. Look at that. Yeah. Nearly there. Just Toby and Andy now. Oh, there's Andy. Got Andy. Whoop, whoop. Just Toby to go. Where's somebody messaged Toby? I'm the fourth arrived. Really? Oh yeah, Con was there. Con was there. Yeah, just Toby. Mark, Toby is missing. Someone sent him a message saying Toby is charging his Mac. Okay. Cool, guys. We're good to go. Whoop, whoop. Yeah, that was a quick reg, wasn't it? Look at that, register done in 2 minutes 22. Yeah, we're on it. Right, okay, guys. Share my screen. Today's lesson, you guys have had no homework, which is amazing. I gave you guys a break from the homework. So, guys, today's lesson, solubility rules. Solubility rules. Sorry. Okay, only 2 learning objectives today, guys. And can I just point out, by the way, that the learning objectives are both knowledge-based. Like, you don't need to. I can give you a little bit of explanation behind this if you really want it, but in reality, you don't need it. Like, I can talk to you about why, but it goes into bonding to a level which is not required at GCSE. It's AS level to understand this. Happy to do so, but just 2 clear learning objectives. Number 1, I need you to know your rules. Yeah, key thing. You've just got to learn them, guys. I will give you guys. I'll give you guys some questions for homework, but I need you guys to know your rules. And I know it sucks having to learn stuff. And I always say, learn as little as possible. But there are some bits of chem which it's just easier just to learn. I'll make it as easy as possible. So you need to know your solubility rules, and then we're going to talk about the methods of salt prep. And there's 2. Is that right? No, there's 3. Technically, there's 3. I'll put methods of salt prep. Yeah, that's all right. And we'll talk through those. Okay, so solubility rules are actually not as bad as it seems. So this is it, folks. This is all you need. Yeah, 3 things. Nag-sag. It's a stupid word, I know. And the hilarity about all of this is if I'm just going to sum it up, that's what I need you guys to know. PMS and Castro Bear. Yeah? Because we students often ask me what makes something soluble and what isn't soluble. And I'm actually gonna. I don't need you to really write this down because I'm gonna write it with you anyway. It's always good for me to learn it as well, to go over these things, reinforce it in my head. So I'm gonna be doing this with you, and I'll talk to you about this. So the title is Solubility Rules. Solubility Rules. I'm gonna go for black. Let's go for black. Solubility Rules. Okay, solubility rules. Okay, so we've been doing all of our calculations in our acid base. We've been doing an awful lot of chemical equations, and we've been seeing the fact that we can start to predict the products that we're going to make. So, for example, let's go question number 1. Let's do HCl and sodium hydroxide. On the chat, please. What are my 2 products? Off you go, quick as you can. What are the 2 products? And on the chat. Question number 2. Let's go for sulfuric acid and look at that, salt and water. Ruby specific, please. I'd like a bit more detail here. Come on, Tong. Thank you, Ashley. Ashley holding up the team there. Can't in second place. Rue's now fixed his mistake. I love that Kieran's put knackle. I don't know what knackle is, Kieran, but I like it. I like it a lot. Let's go for sulfuric acid plus calcium hydroxide. What am I going to get now? Well done to those people on the chat. Well done. NaCl and water. I like it. And I'm going to flag up this as salt. What am I going to get? Thank you, Ruby. No need for the capital L on the chlorine. In fact, it needs to be lowercase. Ben, I like it. Ben's on the naming of the product. I like it. Ben, can you convert that to a symbol, please? And give me the other product to boot. There's Kieran. Well done. Great job. I love the fact that Rue has even balanced it. Well done. Good job. Ruby, there's no oops here. You don't need to worry. You're not going to be typing something in your exam, so it's absolutely fine. Con balanced it as well. Amazing. When water and calcium sulfate. I love the fact that you guys have got all the formula great, which is superb. We're going to form calcium sulfate and water, and it would indeed be balanced like that. There we go. And I'll then label this as salt. Yeah. So what singular word, yeah, tells us that these are salts? Yeah. What word links these 2 compounds together that I could switch for the word salt? Yeah, salt / what word defines this as a salt? Thank you, Con. He's all over it. Yeah, good job. They're ionic. Well done. It's lovely to see bonding being so quick as well. Ben, outstanding. An ionic compound. Superb. Yeah, well done, Kieran. Good job. So the next question now is if we're making salts during reactions, yeah, so not all salts are soluble. We know this. We know that some are soluble and some aren't. Well, the question is, can we predict them? And the answer is you can. And there are 3 rules. 3 rules. Chemistry rules. Number 1. Everything is soluble. I love that rule. It makes me laugh. Yeah. And I know that seems odd, but essentially, I shouldn't really put that because that is fundamentally flawed. And everyone's going, what? You've just written, not all salts are soluble, and then rule number 1 is everything is soluble. Isn't like, there's obviously something odd here. Yeah, everything is soluble, except. And then you get your 2 other rules. Yeah? And actually, it's surprising because what that means is that most things are, and there are a few that aren't. Yeah? So rule number 2 is PMS. Yeah? PMS. So would anyone like to tell me what PMS stands for on the chat? I'm not entirely sure whether it's appropriate for me to ask that. I think it is. I think I'm allowed. Does anyone have any idea? I love everyone's gone quiet on the chat. I can say what SPM stands for. I have no idea. Premenstrual syndrome. Oh, it's amazing. Ben, you're not wrong. Oh, that's so funny. I shouldn't laugh. Oh yeah, okay. Rue's giving me a Malaysian one. I like it. So Ben's answer is not correct, and neither's Rue's. Neither of them are correct. What it stands for is PB, lead, M, mercury, S, silver. I know that you guys aren't going to really like that because you're like, you've got one as it's probs something. Lead, mercury, silver. Thanks, Shan. Why did you laugh? Oh, come on. It's brilliant. I think it's hilarious. So lead, mercury, and silver. Oh, my Lord. I saw it earlier. Yeah, absolutely. It's PB something. Yeah. Isn't that kind of inconsistent? Yes, Kieran, it is, but I needed to make it easy for you to remember. And PMS is easy to remember. Yeah. Otherwise it would be LMS. Yeah. And PMS is funnier. Yeah. I like PMS. It's funny. So lead, mercury, and silver. Rule number 2. Now, this rule is going to get linked to the first rule, and that's where NAGSAG is about to come in. Yeah, NAGSAG. I should put everything as soluble except. I should actually include in everything as soluble NAGSAG. I should actually put that in there. Yeah, I should at that point include that. NAGSAG. Yeah. Yeah. Except. So, don't worry, I'll explain NAGSAG. I'm going to write that properly anyway. Rule number 3 is Castro Bear. Yeah, Castro Bear. I'll put in brackets Castro Bear. Yeah. And honest to God, this is the best way I've ever learned to teach this. It's what I wish that I had PHA, LMS. Yeah. Oh, I see what you're doing. Lead, LMS, yeah, mercury, and silver. That's weird that you've put PHA. Lead is PB. It'd be PH and S, right? PHS. HAP. I'm going to ignore all the chat from now on. So there's 3 rules. Suddenly realize I've missed my 3. Yeah, 3 rules. Castro Bear, PNS, and then everything else. So how does this now get linked to NAGSAG? So we need to now write down what each of these translates to. So rule number 1 was everything is soluble. Yeah, I feel like it's a really good name of a song, that. Everything is soluble. And we get NAGSAG. Yeah. Notice the line. I'm actually going to do the line in a... Yeah. I'll do the line in red. Why not? And then SAG. So we've got nitrates. Nitrates. Acetates. That's a tricky one. Acetates. So the acid to produce the nitrate, so this is acid made from, yeah, is nitric acid. Yeah, nitric acid we know makes nitrates. The acid for acetate is acetic acid. Yeah, acetic acid. Can anyone remember what the proper name? That's an old name. Can anyone tell me what the proper name is for acetic acid? I wonder if people can remember. And then the next one is group 1. Group 1. Now, just check that this matches my picture. Yeah. So the reason why I do this is because what you'll notice, so these are group 1, this is group 1 metals. Acetone, no. Shan, acetone, ethanoic there, Ashley's on it. Rhumine carbonic, nope, not carbonic. Well done, Ashley. It's ethanoic. Yeah, otherwise known as vinegar. Yeah, ethanoic acid. Okay, now these three here, always soluble. Truly always. Yeah, hence the first rule. Yeah, the first, I teach nags, it's the only one I could think of. Oh, fair enough. Ethanoic, it's the correct answer. So these guys are technically the real rule number ones. All nitrates are soluble, all acetates are soluble, all group 1 salts are soluble. Yeah, so these are the true number ones. And then we get this rule 1.5. This is how rule 1 links to rule 2. Now the next one is these are sulfates. Sulfates, we've got ammonium salts, and we've got group 7. Yeah. Okay. So we've got these guys. Now these guys are the ones, these three, can I just point out that technically I should put nag sug, yeah, because all ammonium salts are soluble. Yeah. So technically the ammonium salt should actually be up in this group, but then it doesn't make it as easy to be able to say nagsag. So I know. I'm doing tricks here to try and help you remember this, folks. I just am. I'm sorry. Yeah. And now this is the bit that now links to the next 2 rules. So we know that. I'd like to make that a bit thicker. There we go. So these guys have exceptions. Exceptions. So can I just point out, I still like the first rule. All sulfates are soluble, all ammonium salts are soluble, all group 7s are soluble, except. Yeah, this is the exceptions to it. And this is where PMS comes in. So PMS, lead, mercury, and silver. Yeah, now lead, mercury, and silver tie in to both groups. Now I'm going to color code this, guys. Going to color code this. Please do the same if you can. Yeah, so PMS, lead, because it's PB. Yeah, mercury, and silver. And these guys get tied to both the sulfates and the group 7s. It gets tied to both. What that means, what this exception now means, is we can now do the examples. So if we had lead 2 sulfate, it is insoluble. If we have mercury, Hg, a hug without the U is just toxic. So, see, hug without the U. Hug without the U is toxic. No. Oh. So mercury sulfate, insoluble. Yeah. Silver sulfate, insoluble. Yeah. All of these. Wow. That's Kieran just put dots. Just no. I swear I saw that somewhere. That's probably true. I think cringy. Thanks for that. So these guys are now insoluble salts. Yeah. So you learn nag sag, you go, oh, the nag's always soluble, but the sag is a bit saggy. Yeah, they're just a little bit, they kind of sag in the middle, or actually at the edges, because ammonium's in the middle. Oh, I'm going to stop. I'm sorry. So then we go, what other rules do we pick up then? We've also got the group 7s. Yeah, so we've got lead 2 chloride, insoluble. We've got mercury, damn it! Mercury 2 chloride, insoluble. Yeah, you can do this with any of the group 7s if you like. Silver chloride, insoluble. Yeah, silver bromide, insoluble. Iodide, white, cream, yellow. It's nice to bring up that again. Nothing at all, it's all there, guys. Nothing ever vanishes. Silver bromide, insoluble. Silver iodide, insoluble. Yeah, and we know that this one here is a white. This is your white solid. Yeah, then you've got your can't do this. Oh no. I don't even know how you do cream. And then you have your cream solid. It's not really cream, is it? That's pink. I don't like it. Hang on a minute. Cream. More colors. Cream? Yeah, it's like that, isn't it? Yeah. Your cream precipitate, that's your cream solid. Cream precipitate, and then you get your yellow. Yeah, we remember doing all this stuff. Yeah, we then get our yellow precipitate for the silver iodide. We remember this on chemical tests. Yeah, silver solid, silver iodide. So these are all precipitates. They are all insoluble. There we go. There we go. They're insoluble. Ooh, feedback hub. No, go away. So PMS, super handy. Yeah, and all you actually need to do is remember SAG. Technically, it's SAG, PMS, and Castro Bear. Yeah. The next one is, again, requires a little bit of talking through, because now what we need to do is, now that we've done PMS, I could even put it in its box. I quite like it in its box. Look at that. PMS. We now need to do Castro Bear. Yeah. I think what I'm going to try and do is, I'm tempted to move that. Let's move it. Let's move it. Oh no. Oh no. Let's get rid of that. There we go. So, really useful rule to have. Now you pick up Castro Bear. Yeah, I'm going to do this in a different color as well. I'm going to do this one purple. But I want it to be thicker. Yay. Castro Bear. And this is calcium. Yeah, calcium. I made this a lot bigger than the last one. Shrink it. Zoom in. Yeah, Ca Castro Bear. Yeah, calcium, strontium, and barium. Barium. Barium's obviously Italian. It's a very Italian element there. Barium, barium, barium. Yeah, it's very Italian. So Castro Bear also has exceptions, but now it is only the sulfates. Yeah, so calcium sulfate. Yeah, insoluble. Strontium sulfate, insoluble. Barium sulfate, insoluble. Yeah, so and that's it. That's kind of it. Please note that they're all in group 2. Castro Bear is a group 2 rule. Notice they're also at the bottom half of the group 2. When you go to the top, so you go to beryllium and magnesium, they're soluble. It's kind of cool though. And that's it. Those are your rules. That's it. 3 rules. Everything is soluble except for SAG, where the sulfates, of course, have got 2 stars and the chlorides. So it's not too complicated. What we now need to do is we need to look at this in regards to equations and reactions. So now this is going to get a bit more tricky. Question 1. Write equation. I'm going to start off easy and get harder. Write equation for silver nitrate and sodium chloride reaction. Include, this is where the first time you'll ever see this, include state symbols. It's very rare to see that at GCSE. It's usually 1 on an entire GCSE paper. It becomes more common at A-level, even still, though it's still particularly rare. It's not common, but include state symbols. So we assume that everything is soluble. Yeah? Everything is soluble. Silver nitrate, sodium chloride, aqueous, everything is soluble, goes to form silver chloride. An exception to the rule. Key rule, nitrates are all soluble. Yeah, that stands out. Now that's where we pick this up. And then, of course, we get sodium nitrate, and all nitrates are soluble. Yeah. So there's your exception. Yeah. And unfortunately, guys, you've got to know them. And PMS and Castro-Bear tell you all of them. That's it. That's all you need to know. Sulfates of group 7s. That's it. It's not as hard as it sounds because the rules actually aren't massive. Yeah. Question number 2. Let's do lead nitrate rule. All nitrates are soluble. Yeah. Lead nitrate plus potassium iodide. Oh, all group 1s are soluble. That's a great rule, isn't it? Everything's soluble. Yeah. Right, we're going to switch the methyl. Yeah, this is a true displacement, by the way. True displacement. Swap the methyl. Potassium nitrate. Soluble. All nitrates are soluble. No exceptions to the rules. Yeah, aqueous. But we're now going to get lead iodide. Ah, so that's the problem. We're going to need 2 there. Going to need a 2 there. I think I'm done. Yeah, I think so. Okay. So, and this one's now a solid. Lead is in PMS and it's group 7 and the sulfates. So this one now is the exception. Yeah. And this is what I mean by application into equations. Yeah, being able to recognize our exceptions when they appear. Yeah, I know it seems like an awful lot to take in, but it's not as bad as it seems. Okay, here's something a bit more of a challenging question. So, okay, this is a bit of an old school question for you guys in year 10. So, reactivity. Reactivity. ... Which metal in group 2 is the most reactive? On the chat, quick as you can, find your periodic tables. Table les périodiques. It's French periodic table. Which metal in group 2 is the most reactive? 1 mark. They're then going to say, explain your answer. Explain why. And that's going to be 3 marks. Oh, Ben's gone the wrong way. It's gone the wrong way. I don't know what beryllium is anyway. Ben, have you developed a stutter? Beryllium. What? Ashley! Good grief. You haven't even got a table in front of her, have you? Thank you, Tong. Yeah. We learn. Whoa, didn't want to do that. There we go. We learn that the metals, to all of these guys, yeah, the metals get more reactive down the group. The most reactive group 1 metal is cesium. Francium doesn't count because it's rare. Because more shells, so bigger atomic radius, so loses electrons easier. Thank you, Kieran. Love that. And he is correct. Reactivity of metals increases down group. What about radium? Isn't it at the bottom? We don't talk about radium either. Radium is, again, radioactive, very rare. It's just something we don't play around with. If you they'd say, which one's the most reactive from lithium to cesium? They'll cut it off for you. Yeah? But we never talk about these guys at the bottom. Anyone who's radioactive, you can ignore. By the way, and there's a way of using the tables. I bet you didn't. Does anyone know this? How do you know if there's an element that's radioactive on my table? My table tells you. It tells you, but it exists. Yes, it does, Rue, but I can't imagine anyone who's actually extracted. Or does it? I like it, Ruby. Has anyone spotted how you can tell if something's radioactive? Rue's on it. It's the square brackets. Yeah, if you've got an element with square brackets, radioactive, 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 all the big ones. Yeah, all the big ones are radioactive. Yeah? So we just never really talk about them. Technetium's an oddity of the table. Yeah, but isn't that cool? The table tells you everything. So much. the most beautiful thing in the world. It makes me cry every time I learn something new about it. Anyway, so explain why. Well done to Kieran, smashes them out the park. So the correct answer is barium. Barium. So we'd expect that barium is the most reactive metal, barium solid. Yeah. They're going to ask us why, and you say most shells, more shells compared to any other group 2. Most shells, outermost electrons are further from the nucleus, therefore more easily lost. We know that metals like to lose electrons. That's what metals do. Metals love to lose electrons. Love. Most shells, outer furthest from the nucleus, more easily lost. 3 marks. Boom, boom, boom. So, knowing key things like metals want to lose electrons is so handy, you know. In reality, that kind of underpins the understanding of what's going on in terms of reactivity. It's kind of nice. Kind of cool. So, question number 4. Question number 4. Barium metal plus sulfuric acid. So, first of all, can everyone give me the products of this particular reaction, please? Barium metal plus sulfuric acid. What am I going to make? I wonder if I can find a video of someone who's done this. We don't have barium in school. We're not allowed to have it in Malaysia. It's deemed too dangerous. I have used barium before, though. Barium is very toxic as well. Barium ions are toxic. Thanks very much, Rue. Thanks, Kieran. Come on, everyone else should have been there earlier. Thanks, Ashley. Metal plus acid goes to salt and hydrogen. Yeah, mash. Because it's 2 H's. Mash. Yeah. So we're going to get salt, barium sulfate, and hydrogen. I like it. The gen telling us that it's in a pair. Any element ending in gen is in a pair. So, now let's apply our state symbols. What's the state for water? What's the state for sulfuric acid going to be? What's the states for all acids, please? What's the state symbol for this guy? What's the state symbol for this guy? What's the state symbol for this guy? Rue, well done. All acids are aqueous. Well done. Good job. What's now the state symbol for barium sulfate? Got 6 people doing well on the chat. Loving it. I'm loving it. Should I submit the reg? Tongue's on it. So's Kieran. Ben's not. Neither's Ashley, although they might be answering a previous question. Barium sulfate is a solid. And hydrogen, of course, is a gas. Barium sulfate is one of our exceptions. Castrobare. Yeah? The sulfates of the group 2s are insoluble. Now, this reaction is rather interesting because what you would expect, I wonder if there's a video. Yeah? What you would expect is here's our beaker. And that's labeled as sulfuric acid. Most people, and here's our little chunk of barium. Yeah? Little chunk of barium. Hey, barium. Little chunk of barium metal. And we're going to throw it into the water. Yeah, we're going to drop it into the water. Now, that should be a very, very, very scary reaction. Guys, it is the most reactive of the group 2s. Yeah, this should explode on contact. But in reality, no reaction. There is actually a very small reaction at the beginning, almost none at all, but you would actually say no reaction. It should explode. Our expected explosion. Instead, expected explosion, ... Instead, bored. Yeah, we were expecting this massive explosion because barium's so reactive. But here's what's actually happening. The B in the barium stands for buzzkill. I like it. Nice one, Ashley. So here's what's happening. Here's the chunk of barium. Yeah, here's the chunk of barium. And the barium is falling. Yeah, it's falling towards the acid. Here's the acid surface. Yeah, it's falling towards the acid. And when it actually lands in the acid, yeah, upon contact, what do we see happen? We see something rather interesting. We see, for a fraction of a second, we would see tiny bubbles, and then it would stop. The reaction would halt almost immediately. By the time it gets to the bottom of the beaker, it appears that there's no reaction at all. Now the reason facepalm, and then the barium will just sit at the bottom. So the question is, what's happening? What's happening here, folks? I've done a terrible job. What's happening here is that as soon as the barium touches the sulfuric acid, a reaction happens. And the barium is covered. The barium is covered in a layer. Can anyone tell me what this layer is? What's the layer? I should have actually done it in white. It's actually like a creamy color, barium sulfate. It's actually a creamy color. I'm going to fix that. I'm going to make it more accurate. Yeah. There we go. It's actually more of a creamy color. Cream. Yeah, look at that. No, there we go. I'm so nerdy. There we go. And it gets covered. That's the one. It gets covered, not in barium oxide, Ashley, but in barium sulfate. It becomes coated. Coated. I'll shrink my pen. Coated in insoluble barium sulfate solid. And the reaction now stops. So, reaction stops. It's rather clever. We expected this massive explosion, but because barium sulfate is completely... I thought all the non-transition metal salts are white. Kieran, it is white. It's cream. What are you moaning about? Stop whining. It is. It's not coloured. You're right. I'm just... you're such a... You like to pick me apart, don't you? Barium, it is white. It is. It's just... I know better than most people because I've actually met all of these people. And barium sulfate does have a slightly creamy color to it. It's not beautifully white. It's ever so slightly creamy. Yeah, but it's not colored, so to speak. Yeah, it's just slightly, it's like off-white. Yeah, there you go. It's like an off-white color. Cream is not the same as white. Yeah, I know, Kieran. Oh, God. You're allowed to call it white, all right? It's just me being pernickety because I know stuff. Leave me alone. Leave me alone, Kieran. You call it a white precipitate when you do the test for the sulfate ion. Yeah, it is white. I'm just telling you, I'm just giving you facts here, Kieran. I'm giving you facts. Leave me alone. So the reaction stops. It's rather an interesting thing because it was very unexpected. We did not expect this to be the case. We expected it to be like proper full-on water exploding everywhere, acid everywhere, and nothing. It's just like, oh, that was a bit boring. It's a bit dull. Yeah. Same thing with some others as well. Let's choose another one. Let's choose another one. I want to show you one that's actually really nice. I wonder if anyone's done this. Some people may have done this. YouTube. Doing a YouTube video to watch whilst you're watching YouTube inside YouTube. I don't really think that's very wise. Lead, metal, sulfuric acid. Oh, it's struggling. Give that a go. Oh, I really want a McDonald's now. I love that YouTubeception. It's like, oh, what was the Inception? Inception. I don't think anyone's going to have actually done it. That's a bit sad. Frustrating. Frustrating. You can demo this, and I demo this in school, yeah, to show this process and how it stops it. So I'll draw it out for you. Yeah. The way that you demonstrate this is using lead. Yeah. So another thought experiment. Let's do another question. I don't know what number it is. Let's go back to 1. Lead, metal plus sulfuric acid. What am I going to form, folks? Complete it. Piranha solution versus a steak. Can we watch that? Oh, Ashley, thanks for that. What am I going to get if I do lead plus sulfuric acid, please, folks? What am I going to get? Yeah. Chemistry. Chemistry. So I've lost my mind. Completely lost it. What am I going to get, folks? Come on. Lead, sulfate, hydrogen. Thank you, Ruth. Thank you, Kieran. Thank you, Ben. You guys are getting good at this. Yeah, I'm going to get lead 2 sulfate and hydrogen gas. And you see, this is such a beautiful reaction because lead metal. Let's look at what lead metal looks like. Yeah, lead metal. Lead metal is kind of a dark grey metal. There you go. It's a dark grey metal. And what we've got is we've got some lead sheets in school. Looks like that. There you go. Yeah, got some lead sheeting in school. I didn't want to click it. Oh, no. Go away. We got some lead sheets. So what I do is I cut a strip of this grey metal. This is just to demonstrate this in action. So let's now put on our state symbols. Lead metals are solid. Sulfuric acid, of course, is aqueous because all acids. Lead sulfate is a solid. Yeah. And then hydrogen gas. Yeah, so this one's quite nice because lead 2 sulfate is actually white as well. So this one you get to actually see this actually happen. Because what happens is you start off with this dark grey metal. See if I can zoom in. You start off with this strip of dark grey metal. Yeah, it's dark grey like this. And what I do is I then dip this metal. Didn't need to make it quite so long. I don't know why I did. I take this metal and I dip it into sulfuric acid. Yeah, I'm going to put it into the acid. This is H2SO4. And when you dip it in, you instantaneously see a change. So the grey metal that's going in on top, yeah, the grey metal you see going in, and then what you immediately see happen is you form this white solid on the bottom. I've done it yellow. It is white, but I can't draw white, can I? Yeah, it immediately turns white, and you see lead sulfate. It's quite a nice reaction. So you lead sulfate, lead 2 sulfate. There we go, and the white solid. Yeah, so you get to see the metal turn white immediately. And when I take it out, you have this white layer. You can easily just rub the layer off. Yeah, and then the reaction will continue again. But it's just nice to see how the reaction stops so abruptly. You put lead into hydrochloric acid, for example, you get nice fizzing and fizzes away. But it just stops its kind of dead. Yeah, you form this white solid on the surface of the metal instantly of lead sulfate, and the reaction ends. It's like it's coating it, and it protects it from the acid. That's why the reaction stops. Now, amazingly, if I go to my learning objectives, we've just finished doing salt rules. Okay, solubility rules. Methods for salt preps. I'm not going to do that now. I'm going to end the lesson here. I'm going to set you guys the homework for the solubility rules, just to reinforce it, and then we'll do salt preps next lesson. Guys, that's the end of the lesson. I'll put the homework on the classroom. Homework is for tomorrow. It's dead easy. It's just all over equations and giving exceptions to rules. It's really easy. It's just basically statements. It's not complicated. No, Ben, it's not very long. It won't take you very long to do it. Don't worry about it. It's fine. Fine. It's basically just writing in state symbols. That's it, Ben. That's it. Yeah, honestly, not that hard. Don't worry about it. Right, guys, I will see you guys tomorrow. Have a nice rest of your Thursday. I'll see you guys soon. See you later, guys.